Okay, anybody have that object to material means open that object to material and observe that atomic structure chapter section B. Okay, let's see. Okay, ma, see that four graphs they given, which is the correct graphical representation based on photoelectric effect. We know that photoelectric effect. What is the formula for photoelectric effect? In photoelectric effect, the incident light energy H nu is equal to H nu naught plus Ke, kinetic energy. So from this kinetic energy, Ke is equals to H nu minus H nu naught. Okay, this equation is seems like Y is equals to mx plus C. In this Y is equals to Ke, kinetic energy, and on x-axis is frequency of incident light. Then we are taking a graph between kinetic energy versus incident light frequency. Okay, that intercept is negative intercept ma. Now the line, the graph will comes like this, and this is the negative intercept. This is the minimum frequency. This is nu naught. Okay, nu naught means threshold frequency. Threshold frequency. Okay, now regarding that kinetic energy versus incident light frequency, the graph second one is correct. Means it is this. This is nu naught. And on y-axis kinetic energy is present, x-axis incident light frequency. And one more thing, kinetic energy Ke value, kinetic energy is increases, that increasing the incident light frequency. Incident light frequency increases, kinetic energy increases. That point already we are discussed in photoelectric effect. The next one is kinetic energy is independent kinetic energy is independent of intensity of light. Intensity of light. Intensity of light. According to that, kinetic energy with respect to intensity graph. This comes like this. Just a parallel line towards x-axis. Okay. The next one more graph what they gave, but kinetic energy, number of electrons, number of photoelectrons means ejected electrons is directly proportional to intensity. Is directly proportional to intensity, then the graph will comes like this fourth option. Means intensity with respect to number of photoelectrons is directly proportional to, then that intensity of incident light increases, and then ejected photoelectrons will be increases. That's why second graph and fourth graphs both are correct. Anybody have doubt regarding this concept? This is very, very important. And these graphical representations also we are discussed in our class. In regular classes we are discussed. So photoelectric effect. When the photoelectric effect will be observed, the incident light frequency is more than the threshold frequency. Then only some electrons are ejected, photoelectrons are ejected. So the number of photo electrons ejected is depends on the intensity of incident light, or intensity of incident frequency. But frequency of incident radiations increases, then the kinetic energy of electrons increases, but kinetic energy is independent on intensity. Okay, intensity is directly proportional to number of electrons ejected. More intensity radiations means more number of radiations fall on the surface of the metal, then the more number of electrons will be ejected. That's why intensity is directly proportional to number of photoelectrons ejected. Okay, so regarding that concepts, second graph and fourth graph both are correct. Okay, understand? Now the correct answer is second and fourth, means fourth option is correct. This fourth option is correct. Okay, let's see next question. Second one, what will be the longest wavelength in Balmer series of hydrogen spectrum? We know that hydrogen spectrum contains 5 series of lines. What are those 5 series of lines? Lyman series. Lyman series is present in UV region, ultraviolet region. Next, Balmer series. Balmer series is present in visible region. Fashion series is present in far IR. Far IR means infrared region. Bracket series is present in IR region or infrared region or middle IR region. And fun series is present in, sorry ma, here this is nearer IR. Fashion series is nearer IR and fun series is far IR. Okay, these are the 5 series of lines, hydrogen spectrum 5 series of lines, in which Balmer series is present in visible region. Now we need to take Balmer series. The Balmer series is present in visible region. The visible region wavelength lambda is equals to 400 nanometers to 760 nanometers, is also known as 400 angstroms to 4000 angstrom units to 7600 angstrom units. Now this wavelength, which is maximum wavelength, means the wavelength value lambda is in between this region, means maximum lambda up to 760 nanometers. 760 nanometers we need to choose. See, maximum lambda value in between that 400 to 760, the answer is second option. Let's see, this is 546, 656, 566 and 555. Like that, 4 options are present. Out of that 4 options, in between the 400 to 760 range, which is a maximum lambda value in the according to the options, 656. For example, in any option they gave, in this third option, in this place, maybe 750 nanometers they gave, then the answer is 750. Or 760 they gave nanometers, so 760 is maximum, so the answer is fourth one will comes. So according to the options, 546, 656, 566, 556, like 4 options are given. Out of that 4 options, in the Balmer series is present in visible region. The visible region, according to these options, the maximum lambda value is 656 nanometers. Understood ma? Second question. Let's see third question. Third question is very easy ma, regarding that energy relations we need to observe. So nth order energy. So before discussing that, we know very well total energy is equals to kinetic energy plus potential energy. Okay, it is very clear. Now kinetic energy KE is equals to, already these derivations and formulas we are discussed in our regular classes. Kinetic energy formula is equals to half mv square is equals to minus e square by, sorry, e square by 2r, e square by 2r, and potential energy is equals to minus e square by r, minus e square by r. So therefore total energy is equals to, total energy is equals to e square by 2r minus e square by r, then LCM is equals to 2r will comes. On simplification we will get the total energy is equals to minus e square by 2r. See, this is the total energy. Now let's see, we have to find out the relation between the total energy and kinetic energy. Kinetic energy is equals to e square by 2r. Total energy is equals to minus e square by 2r. Therefore, kinetic energy is equals to minus total energy. Okay. This is the relation ma. Here they are asked kinetic energy and total energy they given. Total energy is equals to minus 3.4 electron volts. Then what is its kinetic energy? Therefore, kinetic energy is equals to minus of minus 3.4 electron volts, then is equal to plus 3.4 electron volts, because kinetic energy is equals to minus of total energy. Then kinetic energy and total energy both are relatively same value but opposite signs. Means the kinetic energy is equals to minus of total energy, or total energy is equal to minus of kinetic energy. That point we have to remember. In the same way, what is the relation between total energy and potential energy? That also we need to discuss. Let's see. Total energy is equals to, total energy is equals to minus e square by 2r. In that minus e square by r place we can write potential energy. Therefore total energy is equals to 1 by 2 into potential energy. So potential energy is equals to 2 times of total energy. 2 times of total energy. So keep it in your mind. They are all students. So total energy and is equal to sum of the kinetic energy plus potential energy. So we have one relation. Kinetic energy is equal to minus of total energy. Potential energy is equals to 2 times of total energy. Okay. These are the different relations between total energy and kinetic energy, and total energy and potential energy. So in that question, total energy they gave minus 3.4 electron volts. What is the kinetic energy of same orbital having that electrons present in hydrogen atom? Then its kinetic energy is equals to 3.4 electron volts. Plus, here it is positive symbol, but total energy have negative sign. That is only difference. Okay, clear students? Anybody have doubt? Let inform to me. Vaibhav, Vibha, Shravana. Shravana is present. Shravana. Yes, ma, Shravana. Whatever you are feeling doubts, inform to us. Immediately. Inform to me. I'll try to solve your doubts and I will explain to you how to read simply and what are the main important concepts. Okay, don't worry about that. Don't fear at all. So we have to do more and more applications. Then only we will get more knowledge. Then we can solve very easily NEET and JEE questions. Okay, first we have to understand the question and what are the related concepts and how to apply that concept. That is the main important. Okay, students, let's see that fourth question. Fourth question, total number of spectral lines in UV region, okay, during the transitions from fifth excited state to first excited state. First, we'll discuss about that energy levels. Okay, let's see this. 1, 2, 3, 4, 5, 6. Like these are called energy levels. How to know where to use the formula? By reading the concepts only, ma. See, how to know the formula means total energy, kinetic energy relation they asked in the third question. Then immediately we have to think about what is the formula for kinetic energy and total energy relation. Immediately, energy of electrons present in nth orbit, that concept related formulas, all we have to keep in your mind. Then we'll get that proper solution. Nischal, understood? Now, let's see UV region. UV region. UV means ultraviolet radiations or ultraviolet region. We know that already. Just now only I explained Lyman series. Lyman series present in UV region means they are asked how many number of spectral lines are observed when the fifth excited state to first excited state in UV region. UV region means the Lyman series. In the Lyman series, lower energy level. Lower energy level N1 is equals to 1 and higher energy levels N2 is equals to 2, 3, 4, 5 up to infinity. But here the lower energy level, what is the meaning for first excited state? This is ground state. N is equals to 1. It is ground state. Ground state energy level. Then N is equals to 2. It is first excited state. So the first excited state is first excited state. First excited state means N1 is equals to 2. But here in UV region, N1 is equals to 1. Means the all transitions means 3, 4, 5, 6. Fifth excited state means N2 is equals to 6. Fifth excited state means N2 is equals to 6. The transitions from 6 to 2 is present in 6 to 2 is present in Balmer series. Balmer series is present in visible region. Balmer series is present in visible region, but not in UV region. So, zero transitions or zero spectral lines. Zero spectral lines are present. Zero spectral lines are present in UV region. Because the spectral lines are present in the spectral lines are present in Balmer series. So the correct answer is fourth option, ma. See here, the main important concept is first excited state, ground state n is equal to 1. First excited state means n is equal to 2. Fifth excited state means n is equal to 6. The transitions are present from sixth energy level to second energy level. Then that all spectral lines are belongs to Balmer series, but not in a Lyman series. Means the spectral lines are not present in ultraviolet region. Ultraviolet region means the spectral lines are belongs to Lyman series. But here no transitions because the lower energy level N1 must should be is equal to 1. Then that spectral lines are belongs to Lyman series or ultraviolet region. But here N1 is equal to 2. N1 is equal to 2. That's why the spectral lines are belongs to Balmer series. The spectral lines are belongs to Balmer series. Understand? So here the number of spectral lines in UV region are Lyman series when the transitions are from fifth excited state means sixth level to second level means 0. When the same question they are asked how many number of spectral lines present in visible region when the transitions from fifth excited state to first excited state means how many spectral lines are present. That question I will solve one shortcut formula, ma. How many, see in this UV region place visible region they gave means in the question how many spectral lines are present means visible region means this is Balmer series. See, just I am changing the question. One more question I am making here. Okay, in Balmer series. So, fifth excited state means N2 is equal to 6. Fifth excited state means N2 is equal to 6. First excited state means N1 is equal to 2. N1 is equals to 2. So, how many spectral lines? Number of spectral lines formula. This formula we are not discussed in our regular class. Now you have to remember, ma. Number of spectral lines is equal to sigma n2 minus n1. Sigma is the symbol for using addition. Pi is the symbol for using multiplication. In mathematics will comes shortcut. Then sigma 6 minus 2 means is equal to sigma 4. Sigma 4 means 4 plus 3 plus 2 plus 1. 4 plus 3 plus 2 plus 1 value how much, ma? 4 plus 3 7, 7 plus 3 10. So total 10 lines are present. 10 spectral lines are possible when the transitions from sixth energy level to second energy level. That all transitions are belongs to visible region, or that visible region is nothing but Balmer series. So like that the question they are changed. Then the number of spectral lines in visible region during the transitions from fifth excited state to first excited state. Like they are asking the question, the answer is 10. A sigma in maths will comes, ma. Let's see. Sigma 10 means what is that meaning? 10 plus 9 plus 8 plus 7 plus 6 plus up to plus 1. For example, pi symbol they gave. Like pi 8 they gave. Like in exams, they will give pi 8. Pi 8 means 8 into 7 into 6 into 5 into up to 1. So that is the mathematics formula. So whenever sigma 4 means 4 plus 3 plus 2 plus 1. Sigma 5 means 5 plus 4 plus 3 plus 2 plus 1. Sigma 10 means 10 plus 9 plus 8 plus 7 plus 6 plus 2 plus 5 plus 4 plus 2 plus 1. That is the shortcut, ma. Understand? Okay. let's see next question. It's very easy question, ma, direct related formula based. The first emission line in atomic spectrum of hydrogen in Balmer series, Lyman series and Balmer series, they are asked. Yes, ma. Fourth question regarding that question without changing in UV region. How many spectral lines are present from n is equal to 6 to n is equal to 2 means 0. But in the same question, how many spectral lines present in visible region n is equal to 6 to 2, then 10 lines will come. For that shortcut formula is equal to sigma n2 minus n1. Okay, Gayatri. Now let's see in Balmer series. Balmer series, the first emission line, first line. Balmer series, the first line. So we know that in Balmer series, N1 is equal to 2. Just now only I said. First line means the transitions from 3. N2 is equal to 3. Means the first line is the transitions from 3 to 2. In that 3 to 2, it's what they're asked. The first emission line of atomic spectrum of hydrogen atom in Balmer lines appears cm, centimeter inverse, means it is the wave number. So in that case, wave number nu bar is equals to, what is the formula for wave number? R into 1 by n1 square minus 1 by n2 square, centimeter inverse. 1 by n1 square minus 1 by n2 square, centimeter inverse. Okay, now this n1, you know that n1 value is 2, n2 value is 3, just to substitute. Then r into, so in our class, regular classes, in r plus rh I said you can use r or maybe rh according to the options. R only they give, capital R. That's why here in the formula just I used capital R. 1 by n1 square means 2 square value is 4 minus 1 by n2 square, 3 square value is 9, centimeter inverse. Simplify that, this LCM is 36. Okay, then r into 9 minus 4 by 9 into 4 value is 36, means 5r by 36 centimeter inverse. So direct formula. So what we have to remember in our mind, in Balmer series, first line means the transition from 3 to 2, first line. This is Balmer series. First line means n is equals to 2. From 3 to 2 is first line. The next line is 4 to 2. Next line is 5 to 2. Okay, so this is this first line is also called H alpha line. The second line is also called H beta lines. The third line is also called H alpha, beta, gamma symbols, gamma line. Next sixth line also we are calling as delta line, means fourth line H delta. For any series, the first line means are calling as H alpha lines, H beta is nothing but second line, H gamma is third line, H delta is fourth line. Like we have to remember. So Balmer series, here int is Balmer series, n1 is equals to 2. Then n2 values 3, 4, 5, 6, like it will start. From 3 to 2 is first line, 4 to 2 is second line, 5 to 2 is third line, 6 to 2 is fourth line. Like the number of spectral lines, all transitions from higher energy level to n is equal to 2. Then that transitions are belongs to Balmer series lines. Okay, next question, let's see. It is very, very important, ma. In hydrogen atom, if the energy of electron in ground state, energy of electron in ground state means what, ma? N is equal to 1. Ground state means that is E1. E1 is equals to N is equal to 1 is equals to minus X electron volts. Then the second excited state means what, ra? Second excited state means first excited state means 2, N is equal to 2. Second excited state means N is equal to 3. If N is equal to 3, then its energy they are asked. We know that energy of electron in nth orbit in electron volts, the formula is minus 13.6 for hydrogen atom, 13.6 into by n square. It is very clear. Now E1 is equals to minus 13.6. That value actually here he gave minus X electron volts. So this En we can also written as E1 into 1 by n square for hydrogen atom. Then which energy we need to calculate? E3. E3 is equal to E1 value. How much they gave, ma? X electron volts they gave, minus X into 1 by 3 square is equal to minus X by, sorry, in hydrogen atom the energy, then second X, He plus hydrogen like atoms, that energy formula is equal to Z square. Here Z square we need to comes. Okay. For hydrogen atom, this is for hydrogen atom. Now for hydrogen like, here it is hydrogen like atoms. En, energy of electron present in nth orbit is equal to E1 into Z square by n square. For Z, hydrogen, helium, Z is equal to 2. Means 2 square value is equal to 4. Means minus 4x by 9 electron volts. So the answer is second option. The answer is a second option. Let's see Aishwarya. I will explain once again. Energy En is equal to, so you have to take in electron volts formula, minus 13.6 into Z square by n square. Then this is also we can write that nth orbit energy is equal to E1 into Z square by n square. E1 into Z square by n square. Okay. Now this is the exact formula, the original formula. So but in this case E1 is equal to how much they gave? X electron volts. Mean this 13.6 place we need to write minus X. Okay. Then Z for helium ion is equal to 2 and